So today, good morning, welcome. We are going to dwell on what differential calculus. So what we start from is that, but before then, remember to like, subscribe, comment, do whatever you want to do whatever you want to do with my post. I remain with the further math teacher. Okay, so you're welcome. Thank you very much. So differential calculus. I just wanted us to introduce ourselves. When people see topic, it's always very big in the head. Say differential calculus. What is it about? And from the post from my previous posts, my voice was not bad enough, so I'm trying to improve on that. Sorry about that. So differential calculus, right? That's what we have here now. The differential calculus. What is it about in essence? What is it about? It's about learning how things change in time. When I started and now it's not the same time. Time waits for nobody. Time is always changing. Okay? Time is always changing. The time I said what I said just now and now, it's not the same again, is it? No, it's not. So time always changes. Time always changes. That's just the truth. So understanding that is what calculus is about. Calculus is you trying to read, interpret meaning to how things change. Okay, how they change. So generally, remember your gradients. They say the value of gradients, how things change. It was at a location, but what we use now is what we call the Cartesian geometry, or called two-sided x and y. That's what everything's always presented in. Most times we have not gone into the three-sided, so we use the two-sided. Knowing that rule of the two-sided, which is the x and y, right? This is normally the x, and then this is normally the what? The y. Okay? Problem? Thank you very much. So we have the x and the y. Knowing that, then we have maybe a curve on it, whatever curve it is. But then maybe to tell you, find how it's changed in time. These 2 points, how they changed in time. Okay? Or so what we do is most times we say, all right, we draw a triangle in it, and then we identify it to the x-axis and to the y-axis. It's not so. Sorry, that's the y-axis and then the x-axis. Okay, that's x2. This will be y2. Then this is y1, and then this is y. This is x1. Sorry. So this is now change in x, and then this is change in y. Is that also? So most times we are finding like the gradient, which is represented as m, most times is what? y2 minus y1 over x2 minus x1. That's the rule. This is the rule. Is that also? And we also know that x2 minus x1 is same thing as change in x. So we are learning differential calculus from first principles, so you understand how it came about, and before the formula, the general formula that came about. So from first principles, we have x2 minus x1 is equal to change in x. But y2 at this point has a value. Y1 at this point generally is called fx. But y2 now, we can also then say that x1 plus change in x gives us x2. Is that also? We just did an exchange to this one, to this way, to this one, this way. So x2 is x1 plus change in x, right? I'm not doing any magic. No magic at all. No magic at all. Okay? So we know that y1 is this, and then y2 is the new value for which the x has changed. So if instead of the x2, we use x1 plus change in x. Okay, so y2 occurs at x1 plus change in x. Okay, is that awesome? So that's the point at which it occurs. So understanding that and putting that into this equation, we have that the gradient, which is actually now what? Our differential. This gradient is another word for the differential, right? That's just what it is, the differential, which we represent as dy over dx. The differential is y2, which is fx plus change in x, f1 minus, it's not minus x there, minus f change in x, which is y1. Okay, is that okay? Forgive me for that. The base was shaking all over change in x. Wow. So this is the differential formula for any value of fx given whatever value it is, which is equal to y. Whatever value function, whatever f is a function of x. Function of x is y. While the function of x is y, the function of y is x. Okay, so the function of x, for any value of function of x given to us, how it changes in time, we can determine that. Remember, it changes, the change is as we move until it disappears. So the change keeps reducing until it becomes 0, right? That's what happens. So it changes is with time and it keeps reducing until it becomes 0. So take for example, just a very basic example. Say for example, this is e.g. right? Find y is equal to what? Let's say x raised to power 3. X raised to power 3. Okay? Plus 2x. X raised to power 3. So we are finding, so find the gradient, dy over dx of x. That's the value, right? We are finding the dy over dx of it. So what should we now do then? We observe it. Okay? This is the rule. The rule that applies to it. So first things first, we get function x1 plus change in x. So this is function x is equal to x3 plus 2x. But what about function x plus change in x? What will it now be? What will it be? Let's go back. Okay. Let's quickly do this. Okay. What would that be? Because that piece is too small, so that's why I'm taking it off here. So fx plus change in x of it is now, in the everywhere you see x, you put change in x. You put x change in x raised to power 3. Okay? Plus 2x plus change in x. Did you see what we did? This is also with x raised to power 3. It's now x plus change in x raised to power 3. x plus change in x, but 2x. That is there. This is 2x. Okay? So we are looking for x. X is an unknown. That's a variable. It can be any number that you want it to be. You see why we use any number that you want it to be? Because real life, we don't have a fixed number. Almost nothing is constant in real life. You know, that's why in chemistry you say at a constant point, at this constant point, most times nothing is really constant. Okay, so things change. So knowing that quite well, now this 3, if you know your binomial rule, which is very simple, we start with 1, 1, 1, 2, 1, 1, 3, 3, 1. How did we write that? Let me show you. 1, 1, then we pick the first one, then we pick the second one, which is 1 plus 1, 2, then we pick the last one. That's it. It's a binomial triangle. That's why they call it the binomial triangle, because you form the triangle. The next one, you pick the 1, you add this 3, you add this 3, and then you pick the last one. The next one, you pick 1, you add this 4, you add this 6, you add this 4, and then 1. Keeps going. So this is for the first power, x. Then this is for second power, this is third power, this is fourth power. So third power is what we're dealing with here now. So expanding this bracket, knowing that it's raised to power, because binomial helps us in expanding what? Brackets. Okay? Knowing that, start from here so that it becomes easier. Knowing that, let me show you how it's done. So you say x3 is 1, right? It's only that. Now, because it's positive, very easy. Plus, the next one is what? 3x2 changing x. As is reducing, the x is reducing, the x, the change in x is increasing. Plus 3. Where do we get the 3 from? This 3, 3. 3x changing x squared. Okay? And plus changing x cubed. Plus, so, plus, this opens this bracket, that's 2x plus 2 changing x. Okay? So this is the value of fx. Okay? This is the value of fx. Now we have gotten everything we need. Okay? Is that also? Remember, it's divided by changing x. This is the rule we have to apply. So let me wipe this one away. It's kind of long, but we are coming together. Remember, we have expanded this bracket. Do it yourself. You see that's the answer you get. Okay? This is 3 times in 3 places. 3 places binomial 1, 3, 3, 1. In 1, 3, 3, 1, the one is reducing to nothing, the other one is increasing to, right? And then you just putting the values. It will be correct. Because the binomial has just helped us like that. And you can see how it's formed. It's still not rocket science, it's mathematics. You put 1, 1, you join them 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. The next one is 1, 5, then the 1, 5, then there's 10, and then there's 10, there's 5 and 1. Okay, so it's like that. You just know it. It will always be so. Okay, it will always be so. So let's do that now. So dy over dx. Bear with me. Dy over dx. Dy over dx is now equal to these values that we have here. Okay, which is x3 plus 3x squared changing x plus 3x changing x squared plus changing x3 plus 2x. You know, we could have, okay, there's nothing to add right now, so we just leave 0 plus 2 changing x, then minus fx, which is minus it now, minus open bracket this value x3 minus 2x, cover your bracket, all over changing x. So this is what we have there, right? This is triangle change. It's easy for triangle to say change in x. Okay? You know, these markers are always very wonderful. Okay? Now, so opening up the bracket, what is clear from there is that this x3 cancels this x3. Is that awesome? And this 2x cancels this 2x. So what are we now left with? We are left with 3x squared changing x plus 3x changing x squared plus changing x cubed, right? Plus 2 changing x all over changing x. Is that awesome? What needs to be removed has been removed. Remember? Okay? But this one's also plus, so it cancels out. Okay? Because of the minus outside, it makes the inside minus. Alright? So quickly, let's just complete this work. So there is a like term of changing x, you bring it out. You now have 3x squared inside here. Why are we bringing it out? So that we can use it to cancel this one at the bottom. Okay? Is that also bringing it out so that we can use it to cancel the one at the bottom? Basic correct like terms. Just say CLT for short, CLT. Correct like terms. That's the new work we are doing. Okay? 3x squared plus 3x changing x stay inside plus changing x squared plus 2 cover the bracket all over changing x. This cancels this, right? Cancels each other. Remember, we now say change in x tends to 0. That is disappearing. It's actually disappearing. As we're going up in that diagram, remember in that triangle, the x is becoming x2, so it's disappearing. So at the point where it totally disappears, so we call lim as x change in x tends to 0. So they say limit, which is the same thing as a dy over dx, and it's called it the limit. It's the limit, it doesn't get past there. The only place you can get to is x2. Okay? Okay. Do we get it? You can only get back to x1. I mean, not when it's highest, it's at x2. When it's changing, it's going back, it's at x1. So at 0, this value disappears to 0, this value disappears to 0. What we are left with is 3x2 plus 2 as our final answer. Do you understand that? That is therefore our final answer. 3x2 plus 2. Okay? Remember our question. From our question was x raised to power 3 fx plus 2x. We're to find what the gradient or find the differential of it. And you see, naturally gave us 3x2 plus 2. This is the differentiation from first principles. But most times they do ask people to differentiate from first principles and they are confused, they don't understand what it means. So it just means that for every time you see x plus change in x, you see that it gives us the answer that is similar to what we have done if we have done it the easy way. But the easy way sometimes is just a way that makes you not to understand the basis where we are coming from. This is where we are coming from. First principles. It's a change in x, okay? Change in x, change in y with respect to x. That's the y over dx. Change in y with respect to x, as x is changing also. So it's increase y over increasing x, or decreasing y over decreasing x. That's what it's about. Is that okay? Thank you very much. God bless you.